Welcome back. Hope you guys enjoyed the first part of today's lesson. Second part, we're just going to go a little more advanced with some of the properties of exponents for today. Please know that you can pause and replay these videos anytime you want so that you can hear an explanation again. If you have questions after that, feel free to contact Mrs. Compo or myself during office hours or outside of office hours to get your questions answered. We're here to help you guys any way we can. All right, I'm going to go through 3 more examples on this slide just to give you some examples of properties of exponents before you guys practice on your own. First example, let's look at if we had a quotient x squared over 3 being raised to the third power. Well, once again, we've got a set of parentheses being raised to the third power. So that means we've got to take x squared over 3 times itself 3 times. Reference what you understand about multiplying fractions together. You take the numerator times the numerator times the numerator over the denominator times the denominator times the denominator. X squared times x squared times x squared is x to the 6th. There are 6 x's being multiplied together there. 3 times 3 times 3 is 27. That is the simplified expression for that problem. Next problem we're going to go through. What happens if we were multiplying 2x by 3x squared? Does the order of multiplication matter? No, it does not. So let's reorganize the multiplication so that it's a little easier for our eyes to look at. So we're going to multiply the constants together first, followed by the variable expressions. There they are. 2 times 3 is 6. X times x squared is x to the 3rd. That is our simplified expression. Okay. Last example we're going to look at on this slide is negative xy cubed all to the 4th over xy squared. So this is now when we're starting to combine properties of exponents into a single problem. So first, what's that negative doing inside the parentheses? Well, that really means there's a negative 1 times x times y cubed to the 4th. So there are 3 values being multiplied together in that first set of parentheses, all of which need to have this exponent of 4 applied to them. So we're going to raise negative 1 to the 4th power. We're going to raise x to the 4th power, and we're going to raise y cubed to the 4th power. Don't need to do anything in the denominator for the time being. All right, negative 1 to the 4th power. So we're taking negative 1 times itself 4 times, which is positive 1. X to the 4th is x to the 4th, and y cubed to the 4th is y to the 12th over xy squared. Okay, we don't need that 1 there, so I'm going to rewrite the problem as x to the 4th, y to the 12th over xy squared. Now, looking at the x's, there are more x's in the numerator than there are in the denominator. So I'm going to take that x to the 4th and I'm going to split it up a little bit. I'm going to write that as x times x cubed. All 4 x's are still accounted for. Now that first x is going to match up with the x in the denominator. That's going to help us when we go to divide. The y, we have y to the 12th. So there are 12 y's being multiplied together in the numerator. There are 2 y's being multiplied together in the denominator. So I'm going to take 2 of the 12 y's and write them this way. We're going to group them. And then 10 more y's over y squared. So we still accounted for all 12 y's in the numerator. We just grouped it so that now we can divide out versions of 1. X divided by x is 1. Y squared divided by y squared is 1. So we really have 1 times x cubed times 1 times y to the 10th over 1 times 1. Well, do we need to write division by 1? No, we don't. We don't need to write this multiplication of 1 either. 1 times x cubed is x cubed. So that whole problem simplifies to x cubed y to the 10th.